to actually talk about our solution for the EACM Case Competition 2020 virtual final round. So for the executive summary, we actually start off with the objective right at the center of the screen right now, which is the company Juice Perfect and the implementation of a digital supply network. And we have actually outlined a four-pronged strategy, which involves predictive analytics, digitally connected value chain, customer insights, and finally a dashboard that amalgamates the preceding three strategies. So for the current situation, we are looking at the Western Conference of the United States, which has actually 2 juicing plants, 2 warehouses, and 7 drop-off locations. And the entire supply chain can be actually seen on the right-hand side. So we actually start off by actually analyzing the data, and we actually have used a parallel coordinate plot. So just a brief introduction of what a parallel coordinate plot is a way of visualizing multiple columns of data, which is really apt for this case. So the general rule of thumb is that we ignore all the spaghetti portions of the plot, and we look at general trends that can be shown on the parallel coordinate plot. As you can see from the center of the screen, boxed up in red is actually the relationship between the total weight and the shipping order spread, which is actually defined at the bottom of the screen. So as you can see, the higher the total load, interestingly, the spread of the shipping and order dates are actually lower. So this could actually pinpoint certain trends or issues with the supply chain. Next, we'll look at the return value as well as the delayed reason. As you can see, for all those orders that are being returned, the predominant reason is actually the late arrival due to rotten fruits. Likewise, let's look at the sheet that actually depicts routes data. So may I draw your attention to the right-hand side of the screen, which actually can show you the correlation between the drop-off pickup spread as well as the reason. And the predominant reason for a delay is actually traffic conditions, followed by shipper maintenance and long loading and uploading time.
And in our further data analysis, we noticed that among the states, Colorado, Nevada, and Oregon face high amounts of returns. And on average, the mean quantity of goods delivered late is higher than that of the goods delivered on time. And there are a higher number of trips planned, and it will increase the shipper's probability of delivering late. So how can we move from sequential linear supply chains to digital supply networks, which are networks of dynamic interconnected processes and systems? Internet of Things, it's the key enabler of digital supply networks, and we use it by harnessing information from multiple different sources and locations. And for example, Juice Perfect, they face the problem of goods going bad due to high temperatures. And with IoT, RFID sensors can collect data such as temperature from each carton in each shipment and broadcast it to the IoT gateway so that preemptive action can be taken for rotten juices. Thus, it gives high end-to-end visibility of the supply network and raises customer satisfaction because of fewer customer returns. IoT can also play a role in maintenance of Juice Perfect's new shipping fleet. And we are able to collect specific data such as traffic levels and tire pressure from internal and external sources respectively, and apply machine learning techniques for predictive maintenance, such as through a digital twin via cloud solutions like Amazon Web Services. And this will reduce unexpected downtime of the shipping fleet.
So moving on with the physical sensors being recorded via IoT, we are looking at big data and cloud computing. So for the entire process, we actually identify the supply chain business problems, mapping out the data sources and use cases, and next we'll be setting up the business priorities, followed by solution build phase, and finally the evaluation of the impact. So for cloud computing tools, there are 2 popular ones, AWS and Azure. And finally, for big data tools, Apache Spark and Hadoop, which are actually free.
Juice Perfect currently has 7 different routes by 16 different shippers. And the problem with conventional route planning is that it relies on human decisions, but humans satisfies by choosing less than optimal routes and not react fast enough to changes, such as sudden traffic congestion. We have a vision. What if spare vehicle capacity can be preemptively diverted to trips that are likely to be late? And what if routes can adapt to traffic conditions on the fly? our vision can be actualized thanks to tools in optimization and simulation. For optimization, we have found the following tools suitable for Juice Perfect. We have experience with UOB and OR tools, but not here AI. For simulation, we recommend SEM Globe Enterprise Edition, and using the historical data, we have created a simulation. Moving on to the simulation, we can see a screen recording created using SEM Globe software. The data is true to the numbers in the Excel sheet from which we obtain real-world average historical demands, routes, and locations. We assume a crate of fruit juice to be 40 kilograms and 1 meter cube for all juices. The simulation runs all 7 routes simultaneously and gives graphs, and the results can be exported to Excel.
So for artificial intelligence, there are 3 possible implementations: route editing, as well as for possible tools, there's actually deep learning, which has actually sensory tasks, such as which corresponds to the first one, and this can be implemented with free open source tools such as Keras and TensorFlow. For gradient boosting, there are computational tasks. It's more suited for computational tasks, which corresponds to the latter two, and we can implement it using CatBoost and XGBoost.
So to guide the leadership to make informed decisions in real time, we suggest the use of a dashboard for enhanced visibility. Here we have created a sample dashboard with 4 pages. The first page shows an overview of product and shipping information, in this case specific to the West Coast region. So this page shows the values relevant for the business. For example, total number of products ordered and the total value earned. This page shows the delivery information. The display of the key performance indicators will allow for identification of the exact reasons for poor customer satisfaction. The dashboard will also flag out any mismatch of information, allowing for management to take targeted action. Finally, this page shows the information with a real-time updated map of deliveries happening across the selected region. So with our proposed solutions, we have identified potential costs, but also possible mitigations. There are concerns about integration, the cost of transiting to digital from physical, security and privacy concerns from moving to a cloud, and also resistance to adoption of technology. All these can be mitigated through various measures as listed. So we have strongly hinted at evolution from the traditional supply chain to a digital supply network. This is especially important in the context of COVID-19, where the key will be to build a resilient supply chain that not only seeks to reduce risk, but also is prepared to quickly adjust and recover from any unanticipated supply chain disruptions that occur. So in conclusion, we've identified 5 solutions we can suggest to juice up Juice Perfect towards a digital supply network that is instrumented, interconnected, and intelligent. Okay, thank you.